In this breakout session, we will discuss how to solve the challenge of VPC IP addressing and provide you with the end-to-end automated global routing solution on AWS. My name is DeJuan Lightfoot. I'm a developer advocate here at AWS, and this is Senior Networking Specialist Solution Architect and Kit Chada. Now, before we get started, if you all have questions, I'm going to ask that you please save your questions to the end because we have a lot of information to cover. Now, let's talk about today's agenda. Today's agenda will be covering IP addressing at scale, Amazon VPC IP Address Manager, or IPAM, automating a global network, and then Ankit will be discussing a real-world automated global routing solution. Now, IP addressing at scale. When you first start on AWS, I think it's important that we all level set. You may start with the single VPC with an RFC 1918 IPv4 address block, CIDR block, or IPv6, or bring your own IP. Then you determine if you want to have high availability, so you create a subnet in each availability zone, and then you launch your instances into your subnets. Now, if your instances need access to the internet, you attach in a gateway along with the default route in the routing table of your subnets, and that points to the IGW to provide internet connectivity to your instances. Now, if you have instances like database instances in a private subnet, you'll create a NAT gateway in a public subnet, and then as well as a default route in the routing table of the private subnets that points to the NAT gateway. Now, at that point, you are tracking IP addresses for 4 subnets, 1 VPC. That's IP addresses for 5 locations. I want you to keep that in mind. Now, as you scale, your company grows, and you're tasked with providing connectivity, let's say, to another team that has another VPC. Well, to accomplish this, you determine to use VPC peering, which provides you point-to-point connectivity on AWS between VPCs. Now, at this point, you have 8 subnets, 2 VPCs, for a total of 10 locations that you're tracking IP addresses for. How many of you have managed IP addresses in the audience? Okay, yeah, I like that. Now, your network grows again. You have 2 more VPCs that are added to your network. Well, if you know anything about VPC peering, in order to have communication between each VPC, you have to interconnect or provide VPC peering between each VPC in order for them to communicate, meaning that you can't communicate in between VPCs to reach another. So you decide to leverage the transit gateway, and now the transit gateway acts as the central hub to provide connectivity in between all of your VPCs. At this point, you are tracking 16 subnets, 4 VPCs, for a total of 20 locations. If we did the math, if every CIDR block of the VPCs were /16s, that's over 260,000 IP addresses that you'll have to track. Now, your network, your business grows again, and now it was determined to use a single egress VPC. And so in this egress VPC, now you can do things like reuse your NAT gateway and improve your overall network design and operational efficiency. When this happens, you are tracking 20 subnets, 5 VPCs for a total of 25 locations. And if you did this across 10 regions, you're tracking 200 subnets plus 50 VPCs for a total of 250 locations. Now, I don't know about you, but that's a lot of IP addresses to be tracking. You may be asking, how do you manage that? I got a simple answer. Spreadsheets. Everyone loves spreadsheets. And for for the people in the audience that have managed IP addresses in spreadsheets, there's some challenges with that. One of the challenges that I can think of is, let's say you're storing your spreadsheet centrally, and I need to make a change to the spreadsheet. Well, if one of my colleagues is in the spreadsheet, has it locked, I can't make the change. Or let's say it's Friday at 4 o'clock, and somebody asked me to add an IP address block. Well, I may add that IP address block, but it's 4 o'clock, I got to make a run, and I forget to update the spreadsheet. There's many challenges with this, so we can kind of talk about some more of those. So what's wrong with this picture? First, you have to update these spreadsheets manually. How many like to update things manually in the audience? Anyone? No one? We don't have ClickOps? Okay. The second challenge is you have limited visibility into the allocation and usage of your address blocks as they're being allocated. If you're managing your network, sometimes you may need to do audits, and it's a challenge if you only have spreadsheets that are maintaining your IP address management. Again, it's hard to scale. It's really hard to scale when you start just using spreadsheets. So what do we really need? We need to be able to automate IP address assignments as we scale. No more hunting for the conflicting IP address on the network. That's a challenge. I don't know if you ever had to do that, but to find the IP address conflict on the network, yeah, you're probably just waiting on the ticket to come in, depending on how big your network is. We also need the ability to assign CIDR blocks faster. And I'll talk about a challenge with that from my own experience in network engineering. Now, a solution that we have here at AWS is going to be the Amazon VPC IP Address Manager, or IPAM. It kind of solves the problems of manually updating and maintaining IP addresses, and we'll go through that here now. Now, what is IPAM? IPAM gives you the ability to plan, track, monitor your IP addresses across all of your regions and all of your accounts. It works for IPv4 and IPv6, as well as bring your own IP. It gives you the ability to automate your IP addresses, monitor your IP addresses across your network, and also provide retrospective analysis. And we'll kind of cover some of those examples here in a minute. Also, with IPAM, if you have a hybrid deployment, you could actually leverage IPAM for your own premises. You'll have to update those IP address blocks statically in IPAM, but once they're updated in IPAM will not allocate them to any of your VPC resources on AWS. Now, how does IPAM work? Well, before we even talk about how IPAM works, one of the things that we have to think about is our overall routing and IP addressing scheme. If you do this right, those overlapping IP addresses, the challenges that you face in your network, you can kind of limit them. Of course, sometimes we merge with companies and we can't get around it, but if you're starting off with greenfield, thinking about your hierarchical design for your IP addressing is something you really want to do. Now, let's kind of talk about that. The first thing when you're creating an IPAM, you'll create your IPAM on AWS. You create your IPAM in a single region, and then it maintains your IPAM and your pools for all of your regions and all of your accounts. The next thing you do, once you have your hierarchical structure in mind, you start to create your pools. And I'll give you an example of what your pools will look like in real time. And then you set your business rules. Now, this is like the real power of IPAM. When we're talking about your business rules, once you define your business rules, this will allow you to determine that prod gets the prod CIDRs that it's supposed to in the regions that it's supposed to, as well as dev gets the dev CIDRs that it's supposed to in the regions that it's supposed to. Another option with rules is that you have the ability to allocate CIDRs only to specific resources which are assigned to specific tags. So you can leverage tags in IPAM to really control how IP addressing is done in your environments. Now let's look at a hierarchical structure in IPAM. When you create an IPAM, IPAM creates two scopes. You get a private scope for your RFC 1918 addresses, and you get a public scope for your public IP addresses and your IPv6 IP addresses. From there, you create a top-level pool. Here we have a /12, and then you subdivide that top-level pool to department-level pools, depending on how you want to design this. In our example, in the real-world solution that Ankit will use, we're actually using the department-level pool to actually control and influence routing across our regions, which give us that global routing for all of our departments across AWS. And then from there, you start to divide your pools into regional pools. And so here I have an example of a dev pool that's in US West 2 and a prod pool that's in US East 1. And then we complete this process across our departments. And once we define our regional pools, from there we can allocate to our VPCs. And I'll give you a moment to snap a photo. Now, I mentioned that we also have your private scope that you'll have on IPAM as well. Here's an example of an IPv6 RFC 3849 address block in IPAM. You can snap a photo of that as well. Now that we kind of talked about how to set up IPAM, let's talk about how a real-world workflow of IPAM. I can remember being a network engineer, and I would receive a request from a developer requesting a subnet for their workload, their new workload that they want to implement or build. Well, that process would take a day, if not longer. When the ticket would come in, depending on my workload, I would either address it immediately, probably not because I had a large workload, so it would take me some time to get to it. And then from there, I would have to wait on approval for this side of block to be allocated. Then I would have to check our IPAM system, which was probably a spreadsheet, to see if the side of block is available in the spreadsheet. I would have to update the spreadsheet if it is. And then if it is available in the spreadsheet, I would still have to check the routing tables to ensure that this subnet is not in use and in place. Because if there's no route for the subnet, if I allocate it, they're not going to be able to route through the subnet. So I will update the routing, and once I did that, then I could provision the side of block to the developer. If we have developers in the audience, you've probably experienced this process. It can take some time, and it could be a real blocker. So with IPAM, we have the ability to automate your IP address assignment. So when you're deploying your VPCs, this process can be automated to the regions and the developers that they're supposed to be allocated to. As well as we can monitor. It's integrated with CloudWatch. So we can do things like set proactive alarms, and I'll talk more about that in a moment. And then with IPAM, we have the ability to audit for up to 3 years. Let's say an IP address gets assigned to an ENI, and we need to verify compliance or do some auditing. We can actually see where that IP address has been assigned, when it was assigned, how long it was assigned, and how many different ENIs it has been assigned to. This is all that we can do in IPAM. Now, I mentioned that in IPAM, when we set up IPAM, it's actually a single dashboard where we can view detailed analysis. Here's an example of our pool details view where we can actually view our CIDRs that are provisioned, the number of IPs that are provisioned for this particular pool, and the utilization of that pool. We can view this right in a single dashboard in the AWS console. Now, I also mentioned that this is integrated with CloudWatch. So that means that if I need to set up an alarm to say, before my pool reaches 85% utilization, I could actually set an alarm that alerts that prevents that pool from being exhausted. I could take action, maybe assign another pool, or do whatever I decide to prevent that from happening. So this is something I think is really powerful. Now, also with the auditing, you can view, let's say a VPC has been assigned to the wrong region. You can view this right in the dashboard, and you can set up the rules to get clear definition of how this is supposed to be, granular, define this to how you want this in AWS. Here's an example of a non-compliant VPC. Now, for more information on IPAM, here's a QR code that has a detailed blog. Now, I mentioned that we've been discussing greenfield. For those of you that are brownfield, something that I want to mention about IPAM is that the moment you create an IPAM, it will automatically start gathering data from your account. And so what that means is, if you decide on your hierarchical pool, you create those pools, IPAM will begin to backfill those pools. And whatever you define as your business rules or your logic for those pools, IPAM will let you know if those pools are compliant or not from your existing brownfield deployments. Now, we talked about IPAM, and we talked about the journey of AWS. One of the things that I want to talk about next is automating a global network. With IPAM, we're able to automate and get full a visualization of our network and IP addresses, but the real power is when you can combine the tools on AWS, and our real-world solution will be how we present this to you. So let's kind of talk about automating the global network. And when we do this, we first need to look at how enterprises are implementing global networks today. On AWS, you have the transit gateway. And often customers are using the transit gateway to build global networks that connects workloads across regions. Here we have some green VPCs and red VPCs. I'm going to keep this very simple. The green VPCs connect to a green transit gateway. When they connect to the green transit gateway, we can optionally propagate the routing tables of the transit gateway so it'll have the routes for those VPCs that connect to the transit gateway. But we also have to update the VPCs routing tables with static routes or default routes pointing to the transit gateways. Once we do that, we'll have full bidirectional communication between the green VPCs. We have red VPCs. We repeat this entire process. Now we have full visibility between each of the hubs, the green hubs and the red hubs, or the green transit gateways and the red transit gateways. In order for the green VPCs to communicate with the red VPCs, we will have to establish intra-region transit gateway peering. When we do this, we have to statically update the routing tables of the transit gateways, and that's each transit gateway. Now, think about this. This is just 2 transit gateways where we have to manage routing tables. What if we add another transit gateway that we use as an aggregate transit gateway, core transit gateway for our region, and then we connect additional regions? We have to maintain and add static routes for all these transit gateways. Our automated routing solution is going to talk about this in ways that we can solve the challenges of not only updating the transit gateway routing tables, but also the VPC routing tables, because I mentioned in the beginning that we have to update the VPC routing tables as well, depending on your network design. Now, to solve the challenges of managing all those transit gateway routing tables, AWS has Cloud WAN. And when we talk about Cloud WAN, this was introduced in reInvent 2021. So some of you may be using Cloud WAN or heard of Cloud WAN. What this does is it gives you the ability to easily build your global network with dynamic multi-region routing directly out of the box in minutes. It also allows you to connect your data centers, on-premise locations, and cloud resources in a central point of configuration and control. Now, when we talk about Cloud WAN, let's kind of look up under the hood of Cloud WAN. With Cloud WAN, we have 2 regions here. First, you build your core network. this is the part of your global network that's managed by AWS. Next, you determine your regions that you want to have your workloads in with Cloud WAN. And then at that point, Cloud WAN creates regional network edge points in those regions. Now, before you would create transit gateways in those regions. Now Cloud WAN does this and manages this for you. Next, you determine your network segments. These segments are going to be, in our example, finance, HR, and sales. This is where you provide segmentation across your global network. And to really to provide the control and granularity of your segmentation, your routing, you're going to use your network policies. And when I talk about network policies, this gives you the ability to define how many segments you want, how many regions they should operate in, and define which attachments should get associated with which segments. And from there, you begin to attach your branch offices, your data centers, as well as your VPCs to their respective segments. And I'll give you a moment to snap a photo. Now that we kind of talked about setting up and looked up under the hood of Cloud WAN, there's some use cases that we will discuss here. The first is going to be between VPCs globally on AWS. The second is for customers who just want to ride the AWS backbone, so they're connecting to Cloud WAN, and then they're from there connecting to their data centers or their on-site, on-premise locations. And then we have the hybrid use case where you're connecting to AWS and your resources on-prem. But for this example, we're going to focus on the between VPCs use case. Now, if you all remember this slide, when I talked about the transit gateways and how you need to manage each transit gateway route table every time you create a peering connection. Well, with Cloud WAN, now you simply create your global network, create your segments, and Cloud WAN manages this for you. Another great thing, and ANKIT will show you this as well, is that when you actually create your global network with Cloud WAN, that network policy is actually in JSON. So for those of you that manage your infrastructure and code, here's an opportunity to manage your infrastructure and code globally with Cloud WAN. And if you would like to take a photo, I'll give you a moment to do that as well. And for more information on Cloud WAN, here's a QR code. Now, but before ANKIT comes and provides you with a real-world solution, I want to mention that for those of you that already have a global network with transit gateways, you can choose to either integrate or coexist with Cloud WAN, or you can migrate to Cloud WAN. And we'll be sharing a detailed blog post at the end of this session where you can learn more about that. And at this point, I'll let ANKIT walk us through a real-world solution.
All right, thank you, Duan. So up until now, what we have seen is how you can use Cloud WAN to create a global network. Cloud WAN gives you dynamic routing for your multi-region deployment out of the box, and how you can use VPC IPAM to manage and administer your CIDRs for a global deployment. In this section, we'll explore how we can combine these two services and really give you an end-to-end fully automated routing solution. One of the problem statements that Duan talked about was anytime you're talking about a routing solution, currently you have to go into each and every VPC's routing table and put in a static route. And that's the problem that we are really trying to solve with this solution. I will take Duan's lead though and start off with a poll. How many of you currently manage or have had to manage about 10 VPCs in your network? Lots of them. How about 100 VPCs? How about 500? Oh, nice. There's a lot of scalers in here. We'll talk. So let's do this. Let's start by defining this global network. So in this sample network, we are talking about a 3-region deployment, just to keep it simple. The 3 regions are US West 1, US East 1, AP Southeast 1. For this example, we are going to be talking about 3 different departments, or 3 different accounts, if you would. The first one is the finance. They can have their VPCs or their workloads in multiple regions. The second department is going to be the HR department. Again, they can have their VPCs or their workloads in multiple regions. And then finally, the sales department, same story, can have their workloads or VPCs in multiple regions. The major takeaway here is it's a completely staggered deployment that we really want to show. You can have multiple accounts, multiple VPCs, and each account or each account can have their VPCs in multiple regions. Now let's start building on top. Let's throw in a couple of data centers. So we are showing one data center in each geography, if you would. These data centers use direct connect connections to connect back into AWS. Since this is a global deployment, we are going to be using AWS Direct Connect Gateway. And this is a service that lets you connect your workloads globally in any AWS region back to on-prem. So for this example deployment, the Direct Connect Gateway is going to have two legs, really. The first one is the orange lines, which are going downwards into the Direct Connect connections, the private VIFs. And the white lines are the VPC associations that the Direct Connect Gateway has with the virtual private gateways of the VPCs. Now, this part of the architecture takes care of your north-south connectivity. The VPCs can talk to on-prem. So the next gradual step is to start connecting the VPCs themselves, providing east-west connectivity. So for that, we are going to be using Cloud WAN. In this example, we have three departments. So we create three Cloud WAN segments, one each for finance, HR, and sales departments. Then the finance VPCs connect into the finance segment, the HR VPCs connect into the HR segments, and the sales VPCs connect into the sales segment. So net-net, this is the target deployment that we'll be building over the next 25 to 30 minutes. And I'll let you take a picture of this target deployment. All right, so we have defined the target deployment, but haven't really spoken about routing yet. We haven't populated any CIDRs, nor have we looked at the VPC routing tables. So let's change that, and let's start defining the routing requirements, really. So for this example, we are going to be talking about private connectivity only, and that's the major reason why you won't see constructs like Internet Gateway and NAT gateways in this example. You can always take this example and customize it and add more elements if you would. The second thing is we are going to be focusing on intra-department connectivity only. So what that means is we spoke about three departments. If we take the example of finance, the use case would be that a finance VPC in region 1 should be able to talk to any other finance VPC in any other AWS region. And then finally, let's start populating the CIDRs. The on-premises data centers are all within the 10.0.0.0/8 range. And all the department-specific CIDRs have their CIDRs allocated from the 172 range. So finance is 172.16.0.0/16, HR is 172.17, and sales is 172.18. So now let's start looking at the VPC routing tables. If you look at the finance VPC on the left-hand side, the first route you will need is an aggregate route for the on-premises data centers, pointing to the on-premises devices. It will really manifest itself as the next hop of a virtual private gateway. Then in addition to this, since it's a finance VPC, you need an aggregate route for the CIDR of the finance department. In this case, it was 172.16.0.0/16, and it points upstream into the Cloud WAN core network. Let's build on top. Now let's say an HR VPC comes up. The first route is an aggregate route pointing to on-prem. The second route this time is an aggregate route for the HR department's CIDR, which is 172.17.0.0/16. All right, let's add more. Let's say a sales VPC comes up. First route pointing towards on-prem. The second route, again, a department-specific route. So as you can see, there is a pattern emerging here. Every time a VPC comes up, for these VPCs to have connectivity, or the workloads inside of these VPCs to have connectivity, you need a static route for that VPC's department's CIDR. And as of today, you have to manage all of these VPC routes statically. So while we were building this end-to-end automated routing solution, some considerations that we thought of was, firstly, where to store department CIDRs. So we decided not to choose Excel sheets, and we decided to choose VPC IPAM to store department CIDRs. Secondly, the major question is, how do you dynamically update the routing table of each VPC with the correct department-specific CIDR? Now, for that, we built an event-driven solution. And the event that I'm talking about is a VPC getting attached into a Cloud WAN segment. An event by itself is really a JSON object, so it's a collection of key-value pairs, and it includes important information about the said event. In case of a VPC attachment getting created, it includes information like what is the ARN or the Amazon resource name of the actual VPC that got attached, what is the ARN of the actual attachment itself, what was the region where the VPC lives. Now, the next building block that we use is a service called Amazon EventBridge, which is a serverless event bus service. EventBridge allows you to accept these events from various AWS services or your custom services, and it lets you choose targets. So you can accept that JSON object or that event and send it to a specific target. The target that we used here is an AWS Lambda function, and this Lambda function is really a Python script that accepts the JSON object, it parses the JSON object, fetches the right values from the VPCs and VPC IPAM, and then finally updates each VPC's routing table every time the VPC is attached into a Cloud WAN segment. So let's start putting all these building blocks together into an architecture diagram. The first thing that we spoke about was VPC IPAM here. So let's start adding VPC IPAM pools. So we create one pool for the finance department. We put the right CIDR in it, which is 172.16.0.0/16. And for this solution, the net intelligence that dictates which route should be pushed to each VPC's routing table is based on tags. So this VPC IPAM pool, since it belongs to the finance department, it must be tagged with the value of the department name, which is finance in this case. Similarly, you have an HR pool and then a sales pool. Now let's look at the sequence of events from a network administrator's perspective. The first step that happens is, let's articulate the goal again. The goal here is to update the routing table of each VPC with the right department-specific CIDR. And this point really is our North Star. And I can see at least 4 friendly faces in the audience who have asked us for this feature, and that's why we built this solution for you. So from a network admin's perspective, the sequence of events are, firstly, a VPC gets attached into the Cloud WAN core network or into a Cloud WAN segment. Now, this attachment must be tagged as well. So in this case, the attachment is tagged with a key-value pair. The key-value pair is department:\department name. Since it's a finance VPC, the actual tag value here is going to be department:finance. Now, as soon as this VPC gets attached, AWS Network Manager creates an event. And this event is, again, the JSON object that has the important information about this attachment. We take this event, and we accept it in an AWS EventBridge bus. On this bus, we have a rule. Now, at this point in time, the JSON object, or all that information about the attachment, has reached the rule of the EventBridge. This rule has the flexibility to invoke a target. In this case, the target is a Lambda function. So all that good information about the VPC's attachment has now reached the Lambda function. Now, most of you know where this is going. At this point in time, the Lambda function knows the ARN of the attachment itself. So the Lambda function goes back to Cloud WAN and get complete details of this attachment object. Amongst other things, these complete details include the fact whether there was a tag attached to this attachment or not. In this case, there was a tag of department:finance attached to it. So now what the Lambda function does is, it takes this information and it goes back to the IPAM service. And it checks if there is an IPAM pool over there that has the same tag value attached to it or not. It finds a match. That's the first IPAM pool called finance. So what the Lambda function does is, it fetches the CIDR that was attached or that was present in that IPAM pool, which is the CIDR for the finance department, which is 172.16.0.0/16. Once the Lambda function has the CIDR, it creates a prefix list, and it puts this CIDR as an entry inside of it. Now, in case this prefix list already exists, then the Lambda function has the necessary logic to figure out that, okay, this department's prefix list exists, so I don't need to take any action. So it's somewhat idempotent that way as well. Once we have a prefix list, this Lambda goes back into the VPC, and it updates the routing table of this VPC, wherein the target of the route is the prefix list, and the destination of the route is the prefix list, and the target or the next hop is the Cloud WAN core network. And this last step really gives you that automation, and that it automates that configuration element that you would have to do manually otherwise, which is to go into each and every VPC and update the VPC's routing tables. So this is the complete architecture that we built, and this last mile configuration automation gives you the end-to-end routing, fully automated routing that we set out to build in this solution. Now, this is the overall solution that we are going to be demoing over the next few minutes, and please feel free to take a picture if you like. All right, let's see a quick demo of this same solution that we built, and it's a recorded demo. I'm going to be talking over it. So we start off in the VPC console, and right now I'm in the Northern California region because this is where my VPC actually exists. I'm going to be taking the same example that we showed earlier, which is a finance VPC that lives in US West 1 region. So let's look at the list of our VPCs. Let's go into the finance VPC. Now, this VPC has a CIDR of 172.16.1.0/24, which is a part of the finance department's overall CIDR, which was 172.16.0.0/16. And this CIDR is actually saved in a VPC IPAM pool as well. And you can use this VPC IPAM pool to actually vend out CIDRs to these VPCs also. Now, on the routing side of the house, let's take a look at the routing table of this VPC. So you see two routes over here. The first route is the VPC local route, which is for the VPC's CIDR. And the second route is an aggregate summary route, which is 10.0.0.0/8. And the target or the next hop is the virtual private gateway. And this is the route that really facilitates the communication from AWS back to on-prem. So as you can see right now, this VPC does not have a department-specific route. So net-net, any workloads inside of this VPC currently cannot communicate with other finance VPCs in the local region or any other region. Now, the next step is to take a look at the IPAM pools and what we have created over there. So we navigate to the IPAM service and then click on pools. So currently, I have 3 pools over here, 1 pool for each department, namely finance, HR, and sales. And we will dive deep into the finance pool. So it has the finance department-specific CIDR. And the landing page really shows you some important details about this pool. It shows you the CIDR. And since it's a /16, this pool can hold up to 65,000 IP addresses. Now, since the solution is largely based on tags, this is super important. This VPC IPAM pool has a tag that has the department name in it. So in this case, the tag value is finance. The next step for us to take a look at is the Cloud WAN service, and just to look at the configuration of the global network as it exists right now. So the main page shows you a list of all the global networks. We will dive into the global network that we created for this demo. And the landing page shows you this graphic. So the original example required us to be present in 3 different regions, and this is exactly what we have here. This Cloud WAN deployment is active in US West 1, US East 1, and AP Southeast 1. Now, like Duan mentioned, the Cloud WAN policy is really the object that holds the entire configuration for your global network. So let's take a look at the policy. Now, Cloud WAN by default lets you make changes to these policies and track them. So every time you make changes to a policy, a new version of the policy is created. In my example, I had 20 versions, And the policy that we really need to be looking at is the policy that is live and it is the latest. So that is policy version 20 for me. Now this is super powerful. The entire Cloud WAN policy or your global network config is saved as a JSON document or as a collection of key value pairs. And this allows you to integrate this JSON document with your CI/CD pipelines. And that way, it gives you the option to manage your entire global infrastructure with infrastructure as code principles. Let's take a look at some of the important policy details on the UI as well. So this Cloud WAN is enabled in 3 edge locations, which is US East, US West, and Asia Pacific. Since we had 3 departments, we have 3 segments, one each for finance, HR, and sales. Now, Cloud WAN also gives network admins the ability to audit any incoming attachments. So for that, you have this configuration knob called require attachment acceptance. And if it is set to yes, what this means is that if, for example, a VPC wants to connect to a finance department or HR department or any production department or test department, it will first go through the network administrator team. And the attachment will not be live until a network admin actually approves it. So this gives you another level of security. Now, there is another friendly face in the audience who asked whether this can be automated or not. So yes, this can be automated as well. All of these constructs we are showing on the UI or on the console only for the demo purposes. Now, at the bottom of the page is the attachment policy, and the attachment policy is a list of numbered rules. So let's take a look at the top rule. What I'm showing out here is that the rule number is 97, and the way to read this rule really is that any incoming attachment must be put in the finance segment, assuming a specific condition is true. And what is this condition? That the incoming attachment should have a tag attached to it or a tag associated with it. This tag should equal a key of department and a value of finance. So net, every time a VPC wants to connect to the finance department, if you tag the attachment with this key value pair, this attachment policy will ensure that the new attachment will be associated with the said Cloud WAN segment. So talking of attachments, let's go into the attachments page. As of right now, there are no Cloud WAN attachments that are created. So we'll change that and we will create a new attachment. Now you start providing the necessary details to create this attachment. You provide a name. Then you choose the edge location. The edge location is where your VPC lives. Finally, the attachment type is VPC. You select which VPC you want to attach into this segment. Then you select the availability zone and the subnet. And then finally, this is super important. So you need to tag the attachment. As we saw in the previous page, the Cloud WAN policy needs a key value pair of department name to ensure that this VPC is attached to the right segment. Since we want to attach this VPC into the finance segment, we tag this with department:finance key value pair. After that, we hit create attachment. And on the next page, you will see that this attachment is not live yet. It's pending an attachment acceptance. And this is because of the require attachment acceptance configuration knob that we discussed earlier. So we explicitly accept this attachment. Cloud WAN policy knows that it must be put into the finance segment. And at this point in time, you will start seeing the state of this attachment changing. So it went to creating, and now it's available. So at this point, I'd actually pause the demo video to account for the time that it takes for the attachment to go live. So it may take a minute or two for the attachment to actually become available. So now what we have done up until now is net we have created a new VPC attachment and tagged it with the right value and associated it with a Cloud WAN segment. Now at the starting of the demo, we saw that the VPC routing tables had 2 routes. One was a local route, and the second was a 10.0.0/8 route that was pointing towards on-premises devices. Let's see if the routing table has changed now. So we go back into the VPC console, we check out the finance VPC, we go into the routing table, and if you look at the entries, you see that a 3rd route has popped up here. The destination for this route is a prefix list. And the target or the next hop for this route is the Cloud WAN core network. Now let's dive deeper into the prefix list. So the name of this prefix list is finance. This is actually the prefix list that the Lambda function created. And if we look at the entries, you will see that it has the 172.16.0.0/16 CIDR, which is the CIDR of the finance department. So now that the VPC routing table has this route, it knows that any communication for this CIDR or any communication for any other workloads within the finance department is now facilitated. And this really gives you that last automation for the last configuration step of updating each VPC's routing table manually. So that was the demo. What we've seen up until now is really what is the target architecture, and we've seen how it works on the console. Now this is where we'll really start diving deep and looking at the individual events and the JSON policies and the cloud and the EventBridge rules that we use to build the solution. So firstly, it's an event-based solution. So events is where we will start. If you navigate to the core network section on AWS Cloud WAN, there is an events tab. And within this events tab, we are going to be diving into the event that says a VPC attachment is created for the core network. So let's see what this event says. So the event really is a JSON object. And what that is a collection of key value pairs. So what are some of the interesting key value pairs that we used for the solution? Firstly, what is the source? The source is AWS Network Manager, and this is really the name of the service that generated the event. The second one is the region. The region in this case is US West 2. Now this is interesting. Our VPC was actually in US West 1, but the event got generated in US West 2. That is because, as of today, by default, Network Manager always creates the events in US West 2. The next thing that we are going to be trapping on is the detail type, that is the Network Manager topology change. We consider it a topology change because a net new attachment got created and associated into your routing domain. Now, within the detail section, what is the change type? VPC attachment created, because you created a new attachment. The next one is edge location. And this is the target region, if you would. This is the region where the VPC actually lives. So this is also one of the entries that we will be trapping on in our rules. And then finally, there are 3 ARNs that we are going to be using throughout the solution, especially in the Lambda function. The first one is the ARN of the actual attachment. The second one is the ARN of the VPC. And finally, the ARN of the core network. Awesome. So now that we have the rule, remember that the rule was created in US West 2. So for that, we need an event, the event was generated in US West 2. So we need an EventBridge rule in the same region as well, which is US West 2. So now each EventBridge rule has 2 components to it. The first one is an event pattern. And think of an event pattern as a match condition. So what we are going to be doing here is we are going to be matching specific conditions against the incoming rule. What do we want to match against? We want to ensure that it is a Network Manager topology change. We want to ensure that the change type is that a new attachment was created. And finally, we want to ensure that the edge location is US West 1. So net-net, what we are really matching for is whether there was a VPC in US West 1 that was created into AWS Cloud WAN or not. What do we do with this? So what we do is we send it to another EventBridge bus in US West 1. Why are we sending it to US West 1? Because that's the region where the VPC lives, and that's the region where our eventual Lambda function will live as well. So the next step is to take a look at the EventBridge settings in US West 1. Firstly, the rule has an event pattern which is exactly the same as before, but the target this time is different. The target is a local regional Lambda function. So at this point in time, what we have done is we have taken the event, which is the JSON object, and we have transported that all the way to a Lambda function. So the Lambda function has access to all the details of that JSON object. What does the Lambda function do with this information? Firstly, it correlates the attachment tag with the IPAM pool tag. The attachment was tagged with a key value pair of department:finance. So the Lambda function had access to this information now. And then the Lambda function went back into the IPAM service and checked whether there is an IPAM pool that is tagged with the same value. Then the Lambda function found a match. It fetched a CIDR. It created a prefix list, and then added a route back into the VPC's routing table. And this is what gave you that final configuration automation. All right, so at this point in time, let's start summarizing the solution, and let's start taking a look at some of the considerations that we had. Firstly, we built an event-driven solution. It's event-driven because the Lambda function triggers only when a VPC gets attached into the Cloud WAN segment. Secondly, it provided you with end-to-end fully automated routing. Cloud WAN took care of providing you with dynamic routing across multiple regions. And then the EventBridge plus Lambda plus IPAM combination ensured that you can update the routing tables of the VPCs as and when they get attached into Cloud WAN segments. Finally, it integrated AWS Cloud WAN and IPAM together. This one is super interesting. So it gave you an additional layer of intelligence in your routing scheme. So when I say that, think of it this way. AWS Cloud WAN was built to provide you with global routing. VPC lets you create your workloads in a private space. So different services built for different purposes. And because of that, their routing table depths are different as well. Cloud WAN's routing table depth is up to 10,000 routes, and VPC's routing table depth is up to 1,000 routes. So how do you choose how many routes from this 10,000 Cloud WAN routes do you want to punt into the VPC routing table? It becomes an interesting problem to solve. So over here, we provided that logic by using tags and correlating those tags between VPC attachments and IPAM. And then finally, from a consideration perspective, a solution like this would be suitable if you have multiple exit points from your VPC. So if you remember, the architecture diagram showed that each VPC had 2 exit points. There was a northbound exit point that pointed to Cloud WAN, and a southbound exit point that pointed towards your on-premises data centers. And your RFC 1918 addressing space was split as well. The data center owned everything within the 10 range. AWS owned stuff within the 172.12 range. So in a deployment like that, a solution like this would be useful. In case you have a VPC on a stick kind of an architecture, wherein your VPCs are hanging off of, let's say, a Cloud WAN segment, and your RFC 1918 space completely lives behind that routing element, which is Cloud WAN in this case, then technically you don't need an event. What you could potentially do is just put in static summary routes for the entire RFC 1918 range to that single point of exit out of your VPC. So what we have seen up until now is the target state architecture. We have seen a demo. We have also taken a look under the hood, and we have seen what exact JSON elements are we trapping on. The next gradual question is, how can you folks get your hands on it? So what we have done is, we have upstreamed the Lambda code on a GitHub repo. So this QR code will take you to our GitHub repo that has the Lambda function, that has the architecture drawings, and it has the instructions on how you would set it up as well. Since it is on GitHub, we are super duper keen on seeing how you folks would take this solution and customize it according to your use case. And again, since it's on GitHub, we are really, really looking forward to seeing pull requests from all of you. Now, here are some of the related sessions. The first 3 sessions talk about AWS Cloud WAN use cases and also how to build next generation applications with an event-driven architecture. And then in addition to that, we also have a couple of blog posts in here. The first one talks about Cloud WAN and transit gateway interop patterns. And the second one talks about multi-region traffic segmentation with Cloud WAN and transit gateway. And these blogs are a good resource for you to consider if you already have a brownfield deployment where you already have transit gateways and you're considering Cloud WAN as well. And with that, Duan and I would really, really like to thank you for your time and attention. And again, please don't forget to complete the session survey in the mobile app. It's really your ratings and your comments that let us know whether we should keep building such solutions and whether these solutions are useful for you. Thanks, everyone.